Hello, students, getting into the homework from 14.2. So 1, 3, 5, 6, and 7, and then we'll come back and check on the others. So as you take a look, you are finding images based on things like a reflection. And if it has a reflection, just remember it has to be perpendicular. I mentioned in the video for this section a couple ways to do that. One way is to pick a point on the graph, like here, and then measure kind of up to a particular point. So I'm going to go up here. So now notice that I went up 3. So the reflection has to be perpendicular. So I would go over 3. So the reflection would be here. So if this was point A, this would be point A prime. Okay. You can do the exact same thing with any point on the line. So if I go here and I went over 1, that would be like point B. Okay, the reflection has to be perpendicular. So there it is. And there's B prime. You can do the same for the remaining 2 pieces. But again, that gives you the idea. That's really all we're doing with reflections. Okay, let's continue on. So 2, determine which of the following figures have the line of symmetry such that the image of the figure under the reflection is the same as the line itself. Oh, okay, well, that's just different shapes with that. Oh, and I didn't even assign, I went to 3, sorry. Question 3, determine the final result when ABC is reflected in line L and then the image is reflected again in L. So take a moment, build the image, then take that image and reflect the image and see what happens. As long as it's the same line L for both of them, you might see something very interesting. For the following, construct the image of ABC if ABC is reflected in line L to obtain A prime, B prime, C prime, and then A prime, B prime. C prime is reflected in M to obtain A double prime, B double prime, C double prime. Conjecture what single transformation will take ABC directly to A prime, A double prime, B double prime, C double prime. Check your conjecture using tracing paper. I would add you can absolutely do it with tracing paper. You could also do it up here with, I'm going to clear everything here, and you could do it right up here with GeoGebra as well. And I almost recommend GeoGebra because then you can change the angle, whereas with the patty paper and the tracing paper, you cannot. So what do I start with? Start with 2 lines, and they have to intersect. And we'll measure their angle if we need to, but let's take a look. So let's just create 2 lines. Here we are, line. So there's 1 line, and here's another line. Okay, so there's 2 lines. Then I will build a polygon. It said ABC. Mine will be DEF. And let's see here, what else do I have? So maybe I should have done ABC first, just so it matches with what's in the book. Fine, fine, fine. I'll clear everything. Clear all, yeah. And I will build my polygon first this time. So we get an A, a B, and a C. There's my polygon. Now I'll build the lines. Okay, there we go. And I don't know why. I think I double clicked too quick. There we go. There's 1 line. And here comes another line. And it does say they have to intersect at point O. So I'm going to label this point right here. And let's check the settings on it. And I'm going to call this point O, so at least it matches. Capital O, there we go. Okay, now it matches. So now what I'm going to do is I'm going to hide the label of a few other pieces, just so that we can kind of see that it matches. I'm leaving the blue points. The reason I'm leaving the blue points is because when I do my reflections, I could then move them, right? And I have no idea what point I is doing out there. So I'm going to, oh shoot, not that one. Bring that one back. There we go. Okay. So here's O, and there's my triangle. Now it says reflect in line L, then reflect in line M. So select the objects, highlight the objects, right? And then come down, find reflect about line. Click on reflect about line, and then click on the line. It will make it for you, A prime, B prime, C prime. There it is. Now I clicked on the top line first. So now I go back up and I select objects. And let's see here. I want to select all of them. Include those as well, please. There they are. They're all selected now. Just make sure they're all selected. Then come back down and reflect about the line and click on the other line. Come on. Why? There we go. Got all of them. Click on reflect about the line and click. There it is. All right. Now, if you look at the original, and I will change the color of the original so you can see it a little bit better. So there's the original. Original is pink. Why does it? I didn't mean to do that. Stop doing H. There we go. And I'll show the one we ended up with, which is the double primes. I'm going to change the color on that as well. Okay, so red became kind of green. All right. And the question is, how could I get from the red to the green in one swoop? Now, please notice, it doesn't matter what my triangle looks like initially. It won't matter. Is there a way that I can get there? So I could do it. It's possible to have these where like they don't, like my triangles don't intersect at all. So see, I flipped over one of them. I flipped over the first line and got A prime, B prime, B prime. So it went red to blue. Then it flipped over the second one and turned into green. But is there a way that I can turn this in directly? And I'll give you a hint. Center point to A. Guess what? All of those A points. That's impressive. Next one, I'll go center point out to B. What do you notice? And lastly, if you go out to C, what do you notice? So again, we're talking about distances. So the distance from any of these points to a point that's on both of those reflection lines has to be exactly the same. And so maybe you could think, I wonder if there is a rotation, maybe, that would spin. And that's why I drew it this way. That would spin this red one right over here, and it would land right on top of this one. So maybe you could figure out what is that angle, and how does that relate to the angle that's actually between the lines? Okay. Hint, measure some angles. That's why I'm recommending you don't do this with the tracing paper / patty paper, but it is listed here as what they recommend doing. I recommend doing it with GeoGebra. Okay. Let's see here. Same type of thing in 6. Reflect triangle ABC across line J, then across line K. Notice this time the lines have to be perpendicular. So draw triangle ABC, then create a line, then do a perpendicular line to it, and then you've got yourself that 90-degree angle. Do a reflection, then another reflection. I can't tell you how much easier it is to do with GeoGebra. Okay. Reflect the line, describe the single transformation that takes ABC to triangle A prime, B prime, or A double prime, B double prime, C double prime. Okay. Then it says determine whether the same final image is obtained if you reflect across line K. So switch the order that you do it in. So do J first, then K. What if I did K first and then J? Would I get the same image? And that's your goal, to determine that. Let's see here. What's up next? Next up, reflect ABC across line J, then K, then L. Notice J, K, and L form 60-degree angles as shown. So if you're doing this, what I'd recommend is create line J, then rotate line J 60 degrees. That makes line K. Rotate again 60 degrees. That makes line L. And that gives you a pretty good idea of how you can go about doing those. So you'll have 60-degree angles. Make sure they're 60 degrees. When you do your rotation, you can actually type in 60 degrees. If you wanted to not do that, you don't have to. You could do it manually, where you create an equilateral triangle using the rhombus technique. But again, I think that's a little bit too long for what we're doing here. Okay. And then what do we have here? Reflect ABC across line J, then across line K. Notice now we got 45-degree angles. So it does form a 90-degree total, but you're trying to find a single transformation that takes triangle ABC to triangle A prime, B, A double triple prime, B triple prime, C triple prime. Okay. So again, if you're looking for that, you're saying, how am I supposed to do that? Just come up to GeoGebra and let's see here. Let me save this one as triangle under 2 reflections. Okay. And we'll clear that and we'll give ourselves a nice new space. So again, start with your polygon. That's fine. That'll give you an ABC, right? There we go. There's my polygon. Then I will make a line. There it is. And take a look. What do I want? I want a 90-degree angle. So I'm going to make a perpendicular line. So I'll just pick a point and make a perpendicular. There it is. Now, here comes the fun part. If you wanted to, you could create an angle bisector, because an angle bisector is going to give you 45 degrees. Now just hide one of them because I don't need this one, right? And there's my 45-degree angle. So I have my 3 lines, and point D is now my point O. So now all you do is highlight, select objects, highlight the whole thing you want, and then reflect. Now just make sure you read it carefully, because what's it say? It says reflect in J, then K, then L. Okay, so J, then K, then L. So in ours, we could even label these. So if I say label, show or hide label, I say label this line. It did, it called it F. Well, I don't like F. Let's see here if I can do the settings here. Nope, not that one. Will it? There it is, F. I don't want to call that F, I want to call it J, because that's what they told me to use. So I'm just going to call that J. Then I show and label this one, and it says I. No, we're not going to call that I. We're going to call you K. Oh, wait, did I click the wrong? I did click the wrong one. The wrong one highlighted. Show, hide, label, this one right here. So now if I select this one and I go to settings, it's called I want to call that K. So there's J, there's K, and I can even go to move and kind of move these down a little bit because they're not in a great spot and they're kind of right on the line. So I like them a little bit off. There we go, JK. And then the last one, let's see here. I need to show or hide label this one, and they called it G. So I will make sure that I select G and do settings. I don't want G, I want L. JKL. There we go. Done. So now, oh great, I don't want those labels. So I'll unhide those. But I do want the points on the side, because then I can see the primes as I do this. So select objects, I highlight this. I go down to transform, and I want to reflect about line E. There it is. Here's A prime, B prime, C prime. Then what's it say? Now it says take that image. So choose select these images, these pieces, reflect about line K. All right, that'll be great. It does look like it's a little bit more challenging. I need A prime, B prime, and C prime. So if I can maybe move those a little bit just temporarily so I can kind of see what happens. Now I can select a little bit easier this one and then reflect about line L. Sometimes you miss what you were aiming at. There's this reflect about line and click on the line, and there it is. A triple prime, B triple prime, C triple prime. And there it is for me. So maybe there's a way that I could just get from A prime, B prime, C prime all the way down here. I'll let you determine. So again, if you need to, you can right click on settings and just change the color. So again, if we start with pink and I want to end down here with green, then that's, oh, and I clicked on both of them. And I clicked another point F in the middle. Why? Is it highlighted on point F? Oh, must have been. Okay, so I'll click this one and I'll change the settings on this color because I just want that color to be kind of pink. There we go. And then, yes, you could still move it around. You could say, okay, I can move things around. There's nothing wrong with having them overlap, just harder sometimes to grab them. So just pull them apart until you get what you need. Then you can bring them all. You can bring them all together. Look at that. That's kind of fun. Okay, so there you go. Is there a way to get from the pink to the green in one isometry? What would it take? And then test yourself. See if it works. Right. So if you think that you've got it, select the object here and then do the thing that you think it is. So if you think it's a rotation, right? Rotate around point, I'll say around point D, I guess. And the angle is, letting me type that in directly. What if I said, I think it's 120 degree, right? Then this is where it ends up. And you're like, oh, shoot, that's not the one. Well, just undo it and go back and try again. But that's the idea. If you think it's a rotation, a translation, a reflection, I mean, you could try a translation and say, oh, I bet I could just slide that one right down and on. Well, then highlight it and say translate and say then point A is going to end up right there. And you could say, oh, shoot, that didn't work. Okay, that's fine. Try again. So again, trying it this way on the GeoGebra to me is a whole lot easier than trying it using the other techniques that they've said. Okay, so 5, 6, 7 done. We'll skip down. We got 10, 14, 16. So number 10, it says copy the congruent triangles on a piece of paper. Find as many reflecting lines needed to take X, Y, Z to X prime, Y prime, Z prime using successive reflections. Now that is interesting. How many would it take? How many would it take? So that is interesting. And the reason why it's interesting is if you take a look, be sure you check the orientation. The orientation is clockwise here, but counterclockwise there. So if I did one reflection, maybe it could fit, maybe, because at least the orientation would be the same. But if I did two reflections on the starting piece, then the orientation will be back to what I started with, which is not here. So I think it's got to be an odd number. It has to be like a 1, a 3, a 5, a 7. That's how many it should take. It won't be an even number. It can't be an even number, but that gives you a pretty good idea. Okay. I can match that triangle in 3 reflections. You know, that kind of stuff. And then part B says explain why it can't be a translation, a rotation, or a reflection, or a single reflection. Okay, let's move on. So 10, I think it's a 14. Find the equations of the images of the lines when they're reflected in the x-axis. My hint, sketch it out. Sketch out the axes. Then think the x-axis does this. Find points, reflect them over, and then come up with the new equation. I think you'll see a really nice connection between your new equation and the original equation. Okay, that's 14 and 16, 19, and 21. So 16, which line will the two intersecting circles reflect onto themselves? Oh, so I want to reflect, but I don't want anything new to be shown. You can see the circles are not the same size. What line would I choose? And if you want to, yes, you could use GeoGebra for this to kind of practice. 16, I think 19 is next, right? 19 and 21. Yep. 19, if line segment P prime Q prime is the image of PQ, which is not shown under a glide reflection determined by the slide arrow AB, okay, and the line AB, the whole line, answer the following. Describe the transformation that takes P prime Q prime to PQ. So again, it is a slide and then a reflection. So my hint is to undo this, to go backwards and say, okay, what it will be the first thing. So if I did a slide and then the flip, can you undo that by unflipping first and then unsliding? And notice it does say the slide arrow is AB. There's my slide arrow. And here is AB, my reflection line. Okay. So you have to describe the transformation that takes P prime Q prime back to PQ. You're trying to go back in time. Actually, just go backward in steps. Okay, and then construct any quadrilateral D, E, F, G and find its image D prime, E prime, F prime under its glide reflection described earlier. Then apply the same glide reflection to D prime, E prime, F prime and its image D double prime, E double prime, F double prime, G double prime. What single transformation under which the image will be the same? So if you did 2 glide reflections, right, which is the translation followed by the reflection. If you did 2 of those, you're going to think about it. You've shifted over, then flipped over a line. Then you've shifted over, then flipped over the line. What could you do to just get to that end image? And it is a single transformation. And if you look at it, you can do it in GeoGebra. You can kind of think about it. It may not be quite as hard as it sounds. It sounds complicated. I don't think it is. And you're welcome to do this one on patty paper. This one might be a good one for patty paper, so you could do it repeatedly. Let's see here. What's up next? A fixed point of a transformation is a point whose image is the point itself. This is a great question. I absolutely love this question. Love, love, love. Can I give it stars? Can I give this stars? Oh, I can. Oh, what a great question. What a great question. If you have a reflection about line L, which points will actually be exactly the same? If you have rotations by a given angle and direction about point O, what points are going to be exactly at the same spot they were before you started? Same with translation and same with a glide reflection. Okay. Where do I get my fixed points? Where are things not changing? All right. That does it for the homework on 14.2. I'll see you in class, but also feel free to bring up your questions, concerns, issues. I can meet with you on Zoom. I can meet with you in person on campus, whatever it takes. All right, off you go.